So now we're going to do some similar problems, but I want to take a step over and show you what these look like on a graph so you can understand the significance of what these x values are once we find them. So we'll solve this the same way as always. We'll take this 7x, which is a positive, we'll move it to the left side by subtracting by 7x. And this negative 28, we're going to move to the left side by adding 28. So we're going to have this equation in standard form. We have x squared minus 11x plus 28 equals 0. Now we can solve this by factoring. We've got to think what can give us a sum of negative 11 and a product of 28. Well, we're clearly going to have to be dealing with negative numbers here because we have a negative sum. So we could start with negative 1 times negative 28. That, when you add them, is definitely not negative 11. We got negative 2 times negative 14. That would give us a product of positive 28, but it's going to be a sum of negative 16. That's not what we're looking for. What about 3? 3 doesn't go in, but 4 does. Negative 4 times negative 7. Yeah, that's going to be positive 28, and when you add those together, you get negative 11. So those are our two values. We've got x minus 4 and x minus 7 equals 0. In order for this statement to be true, x could either be 4, right, or it could be 7. If x is 7, then you've got 7 minus 4, that would be 3 times 7 minus 7, which would be 0. 3 times 0 is 0, so that's true. And likewise, if you plug 4 in here, you'd have 0 times negative 3, also 0. Now, let's look at what this equation is. This is the same equation typed into Desmos, and let's look at the significance of that 4 and 7. You can see it right here. What we've done when we factor to solve a quadratic equation is we have found the x-intercepts. Okay, another word for these are roots. The roots of the equations, or the zeros of the quadratic equation. So there's different terms for these that were found. Also x-intercepts. So when we are finding the solutions to these quadratic equations, we're finding the x-intercepts, where the parabola crosses the x-axis. And it usually does so at 2 points. There are some exceptions to that, but the ones that we're seeing right now, it does cross the x-intercept at 2 points, or the x-axis at 2 points. Okay, here's another question, kind of doesn't give it to us in standard form, so we're going to have to work our magic. We're going to add 10x. We'll add it to this side. And then we'll add 6. And now we're going to have this expression. We're going to have x squared, let's see, minus 7x plus 6 equals 0. Alright, if we go after this, we need a sum of negative 7 and a product of positive 6. So again, we're going to need negatives. So let's look at 6. Different ways you can get to 6. Well, how about negative 1 times negative 6? That's a product of 6. And, oh, we're going to get this on the first shot. Negative 1 plus negative 6 is negative 7. So now we have x minus 1 times x minus 6 equals 0. So our two x values are going to be x equals 1 and x equals 6. And let's take a look at the graph of this equation, and there it is. We don't have the parabola here. We don't have the vertex of the parabola here, but we do have the other zeros. We found 1, 0, and 6, 0. That's exactly what we have found when we did the equation.